Everyone, it's Larson in the lab, and I'm here with our enzyme Peroxidase Lab. We're using potatoes and hydrogen peroxide today. So potatoes contain the enzyme peroxidase, which is going to break down hydrogen peroxide. So you might have seen this stuff before in your medicine cabinet at home. Peroxide is often used to wash out wounds because it can kill off bad cells that might be there, but it can also actually be harmful to your cells. So your cells in your body, on your skin, have the enzyme catalase that breaks down hydrogen peroxide to make sure it doesn't damage your good cells. And potatoes have a different enzyme called peroxidase, and that enzyme speeds up the reaction of breaking down hydrogen peroxide so that it will not damage the potato cells, in theory. I mean, these potatoes are goners, but hey, we're going to see how this lab works. So what I've done is I've done some different treatments to the different potatoes. I have one group that is at room temperature, and I guess you could call that my control group because I've done nothing special to those potatoes. And then I also have two potatoes that explore pH. I have an acid and a base soaked potato. So earlier I soaked this potato in just regular old vinegar, and that is acidic. These potatoes were soaked in Windex or window cleaner, and that is going to be our base. Over here, I've got where we're going to explore some different temperatures and their effects on peroxidase. So these potatoes were recently heated. I actually microwaved them. You could do this at home if you wanted to. And these potatoes have been sitting in this ice bath, which is ice water. And this smaller beaker was actually sitting down in the ice bath, making those potatoes quite a bit colder than our room temperature potatoes. So what we're going to do is we're going to look at each of these beakers as I put hydrogen peroxide in the beaker, and we're going to see how does the rate of the reaction change based on the different conditions. Let's start with our control group, our room temperature, neutral pH potatoes. These have peroxidase in them, and they should break down our hydrogen peroxide. I'm just going to cover the potatoes in hydrogen peroxide, and we'll watch what happens. So what you can see here is you can see bubbles starting to come from the potatoes. Are you seeing the bubbles? And you can see it bubbling up on the top of this beaker. You can actually see the bubbles coming directly from the potatoes if you look closely there. So this one is having a reaction. The peroxidase in those potatoes is breaking down the hydrogen peroxide. And when the hydrogen peroxide is broken down, oxygen gas is actually released as a byproduct of breaking down that hydrogen peroxide. So you're seeing that reaction take place, and those bubbles are actually the oxygen gas that's being released. That was room temperature. So now let's first start by exploring pH, and that's effects on the peroxidase enzyme. Let's look at the acid. These were soaked in vinegar, which is an acid based on our water lab, and we're going to see how the hydrogen peroxide works with these potatoes. Again, I'm covering them in hydrogen peroxide, and look at that. That looks really different than before. I'll spin this around so you can see a little better. I'm not really seeing very much reaction at all, just a very little bit of reaction, a little tiny bit of bubbles coming from the potatoes, but it's nothing like our room temperature. You can even see from here, our room temperature has bubbles on top because of all that peroxidase breaking down hydrogen peroxide, but that is just not taking place here in our acid-soaked potatoes at a very fast rate. It's happening at a very, very, very slow rate. All right, let's see what happens with the base. These were soaked in Windex, which is a base, as we learned in our Properties of Water lab. Again, I'm covering them, and take a look. What do you notice there? Are you seeing reaction taking place? I'm noticing a lot of reaction. You can see how cloudy the beaker is getting because of all of the bubbles, and you can see the bubbles starting to accumulate there on the surface. I actually kind of feel like this is happening at a faster rate than it did with our room temperature potatoes. So that's kind of interesting to me, that the room temperature seemed like it went at a slower rate than the base. That's bubbled up pretty quickly here. All right, now that we've finished looking at pH, let's take a look at temperature and how temperature affects the peroxidase enzyme. Here's our heated potatoes. These were microwaved. Like I said, you could do this at home if you wanted to try this experiment at home. All right, I've completely covered these potatoes that were heated in the microwave with hydrogen peroxide. And take a look. Nothing is really happening here. I'm not seeing much reaction at all. I'm not seeing any bubbles on the surface. I'm seeing maybe a couple of bubbles released from the potatoes, but very, very, very slow reaction rate here. So I'm not seeing a lot of reaction from our potatoes that had been in the microwave, that had been heated. What did that temperature do to that enzyme? There's a word. It's called denatured. Last but not least, let's check out our frozen potatoes. These are our frozen potatoes. They were in that ice bath over there getting nice and cold. And let's see what happens here. All right, I've covered them. This is happening fairly quickly. I'm seeing a lot of cloudiness here in the beaker. Make sure it's not just condensation yet. It's not just condensation, guys. This is a quick reaction taking place. Do you see the bubbles on the surface? That hydrogen peroxide is being broken down fairly quickly in the frozen or chilled potatoes. So maybe, interestingly, cold temperature makes the peroxidase enzyme speed up. Possibly. I'll let you think about that in your questions here on this properties of enzymes lab and see what do you think about how acid, base, heat, and cool temperatures have affected the peroxidase enzyme. Now, I do want you to recognize that the effects of these different pHs and temperatures will be different on different enzymes. This is just how it worked with the specific peroxidase enzyme in potatoes that breaks down hydrogen peroxide. And you might remember that there are many different enzymes in the human body and in all living things. And each of those different enzymes will need to have different types of conditions, like different pHs and different temperatures, in order to work the most effectively. Hope you enjoyed watching.